welcome to the Passive House 101 series by the Passive House Accelerator, the show where we try to make it accessible for everyone to get into Passive House. My name is Jose, and I will be your host for the next hour. Today's presentation is Airtightness, presented by our own Shaun St-Amour. And just a brief intro about Shaun. Shaun is a certified Passive House tradesperson and the VP of Operations for Clay Construction, Inc., as well as the host of Passive House Accelerator's Construction Tech. Before this position, he was the Outreach and Education Associate with 475 High Performance Building Supply. Shaun is very passionate about resilient prefab passive houses, as well as one of the most recognizable high-performance construction influencers in the US. If Shaun isn't talking about passive houses, he's playing Lego with his daughters or working on his hobby to-do list. With that said, I will encourage you all to ask questions, put them all in the chat. We'll have a Q&A at the end. And with that, I'll leave it up to Shaun.
All right, everyone. Thank you very much for joining me here today. Good morning, good afternoon, or good evening, wherever you are on this lovely planet. Before I get started here, maybe just to clarify a few rules is airtightness is very important, but you do need to incorporate all 5 classical passive houses. And so rule number 2, if you don't know what they are, go back and rewatch that video. You can see it on the amazing Reimagine Buildings YouTube page. And so then rule number 3 is go back to rule number 1 if you're still not clear. Let's get things started today. What is your plan is a line that I got implanted in my brain by James Berger of RDH when it came to talking about high performance. And so what is your plan about airtightness systems? What is your plan about air barrier strategies? What is your continuous airtightness plan? That's what we're going to get into. I've gone back to being a builder, so you're going to get the builder perspective of airtightness. As Jose said, I'm VP of operations at Clay Construction, but I love Passive House and definitely could talk to you about it all day long. And so my passion is, as Jose indicated, resilient prefab passive houses. And yes, they should be affordable. I can, again, you sit me down, I'll have conversations about these things all day long, because the goal of what we're trying to work towards is zero carbon buildings. And the accelerator with Zach have created an amazing equation that I talk about and try to follow every day. Is you look at your operation carbon, then you look at your low embodied or upfront carbon, then you electrify your buildings, you throw on some renewables, and there you go. There you are to zero carbon buildings. And airtightness plays a very important role because the operation carbon is with Passive House and the classic passive principles. So as we're moving to zero carbon buildings, we know that the benefits of Passive House are many, but the highlights that I want to talk about is the comfort, the health, and the energy efficiency, and airtightness will get us there. So yeah, the classic Passive principles, the one that you showed up for today is airtightness. And so we're going to spend some time here diving into airtightness. And what kind of airtightness? Continuous airtightness, where we are wrapping our envelopes, our shells, and making sure that they are continuous. And so if you enjoy gift wrapping, you will enjoy high performance, because this is where people that love gift wrapping have an opportunity to specialize in the airtightness role, because this is what we're doing. We are gift wrapping our buildings. We are putting a bow on it. And all the customers that I tell them this all the time is, gift wrapping your lovely home, stick a bow on it and enjoy, because you will get it as airtight as I possibly can, depending on the design. So let's just kind of give a bit of a perspective of why airtightness is important and a couple of things that highlight airtightness. So we're going to go back to the first Passive House constructed in Germany, in Darmstadt, with Wolfgang Feist. And of course, you saw that I spelled first incorrectly. And for those that have been following along, you understand that when I talk about creating a fun, fantastic, and fast presentation, you know how I'm spelling all those words. So air control is really important in our buildings because we are looking at how we're managing the heat or that comfort zone in our homes. And in our cold climates, we're typically warming up the interior space. And if you're in in a leaky building, all of that warm air is heading out. And so we want to be able to manage the leaks. And what's nice about the Passive House philosophy is the fact that we have modeling software to look at it. So either with PHP or with Woofy, we're going to be able to calculate what our energy demand is, and we will know by the air tightness of the home how we can reduce the air leakage, or how the heat is escaping through those holes. And so as you can see here, you have a bunch of numbers. So typical home, maybe code might get about 5 air changes. So again, that's the air that's going through the assembly. And as we get to the Passive House levels, you can see that annual heating demand significantly reduces, to the point where a typical home could be 90% leakier or less energy efficient as a Passive House. And so you can see here, this particular Passive House got to 0.22 air changes. So it met the requirement of getting below 0.6 and achieved certification. But you can see there that that air tightness level, one of the things that I love about this particular building is that every 5 years they've actually tested this building and it's still maintained it. So when we're looking at building zero carbon buildings that should last 200 plus years, they should also be airtight for the same amount and the fact that we've got a building that has been tested for 30 years and is still roughly around that same air tightness mark, it indicates that the plan that they put forth was delivered, was measured, and is continually measuring to that level, and every one of those occupants are enjoying the benefits. So air tightness is an interesting thing because you can't just go to your local building supply store, walk up to the consumer desk and say, hey, I'm here to buy an air barrier. Where do I buy it? Most people probably won't understand what you're talking about and send you away. If that person is talented, they might say, oh yeah, your air barrier components are on aisle 2, 8, 12, and very back of aisle 18, because you're taking a whole bunch of components and putting them together to connect all the pieces so that continuous air tightness layer is all connected. And so when we're looking at that continuous air tightness, ideally we're taking this pen and we're doing this red line test where you put your pen down and you go around your envelope and it'll all touch. You never take it off. It just comes all the way back home. And of course, then we measure it with a blower door test to ensure that that air tightness goal is delivered as you defined it. So lots of different products. Again, we're lucky with the accelerator that we have amazing sponsors that are helping us. And so you have vapor permeable membranes, self-adhered membranes, fluid applied membranes, the daylighting system. So here's a question for the chat is, which side of a window is the air tightness surface? Is it the exterior or is it the interior? I can't see the comments, so I'll let you guys figure out what the answer is. But the daylighting surface is a very important part to our tightness, especially if they're operable windows or doors. We've got to make sure that they're sealed properly. And of course, making those connections. So the windows are a very important role because for the most part, they've been leaky for allowing heating or cooling to escape, but also through air. And now we have a robust system and component that is part of our air barrier system and strategy. I have to throw this in because again, we've got a lucky, so we've got an amazing sponsor that is all about prefab. And so can you imagine where you design and pre-built off-site in a factory where you have your membranes, your insulation, your structure all together, and then when you deliver on site, you just stitch it? So you're not spending months assembling your airtight layer. Literally within a week, your shell is put together and it contains all the main passive principles. All those components are put together and you have this amazing strategy. And again, what's great with all of our different sponsors is you can buy them online, especially like Source 2050, where everything's come together. So lucky that we have all the materials. So before I give you an example, let's just talk about a couple of guidelines before we deal with some of the air tightness, because I'm really lucky in BC that by 2032, we have policy that is changing so that by 2032, everyone in BC will be building passive houses. And so it's really encouraging that local codes are adapting passive house principles and putting them in there. Either it's going to be a step code, a leap code, or ASHRAE. It's really exciting to see how our North American codes are adapting the passive house principles. And so one of the terms that kind of came out through the BC energy step code was this envelope first approach. And I really like it. So I just want to highlight a few things about it, because the envelope, that shell that gives us shelter, really makes sure that number one thing is it manages water. And if we're managing water, we're also then managing air, because if it's watertight, typically means that it's airtight because water's not getting into our system. Or we've designed our system to make sure that water is going down and out. And secondly, then we're looking at the air barrier. And the air barrier kind of has four main areas to target. You're going to be targeting kind of the connection points: foundation to wall, wall to window, wall to ceiling, and then managing your penetrations. And ideally, you want to put all your MEP, your mechanical, electrical, plumbing, in the interior side of your air barrier, so that you're minimizing the penetrations. Because in a typical home, if you think of all the plugs and switches and lights, you probably have about 200 plus penetrations in your air barrier, and you can get it down to about 12 pretty quickly with just some proper planning and ensuring that your air barrier is continuous, it's robust, and you've documented where the penetrations are. Then you're going to look after your vapor control, and based on your climate zone, be able to manage ideally an assembly and an envelope that is able to dry in both directions. And then lastly, you're going to try to put as much insulation as your client can afford to make sure that they're putting on an amazing sweater on their building. And so when you want to talk to me about BS, the BS that I want to talk about is the building science, because this is where great conversations come to, because the science is there, and now it just comes back on the delivery of how we make sure that our buildings will become comfortable, healthy, energy efficient, is by looking at those guidelines. When you're looking at the envelope first approach, there's some kind of deliverables that are just decided upon from your design team. And so your exterior cladding is really that jewelry. It's the curb appeal on your building. And then we're going to add the insulation. That's the sweater. The weather resistant barrier, again, is part of the gift wrapping. And that includes the windows and doors, the daylighting. And really, I make a note there, that's part of your air barrier strategy. You'll have the structure, which is the bones. And I got to make sure we put in the fresh air machine, because as we improve air tightness, we need to make sure that there's the proper ventilation in your building. So the architect designer is managing the curb appeal. The energy advisor or HERS rater is deciding on what the insulation rating needs to be at, or your passive house consultant. Usually the daylighting, because you're trying to figure out the window to wall ratio of glazing, that's kind of decided upon your design team. The structural engineers involved in the structure. But the builder, this is where I feel like as a builder, there's a key opportunity for the building community to be involved in this, because the builder is the one putting on the air tightness strategy. So as a collective, you've designed it, but the role of the air barrier really falls upon the builder community. You know, you have inputs to the other ones. And then ideally the builder is the one that really needs to enforce that the fresh air machine is put in there. A lot of times you might be looking at different systems or fans or so forth, but the air barrier and the fresh air need to be really on the builder's shoulders. Okay, so integrated design planning is where we come together. That design team works to ensure that all of those different guidelines are incorporated into the system, so that everyone knows the roles, the responsibilities. You've designed your plan, and then it comes to execution. So I have an example here of what we've done. And so we're going to take this particular building and kind of like undo the layers like a onion. We're going to get down to the core of how it worked out. So this is a project in Vancouver. Again, it's a bit of a larger home, but I was able to kind of document it so that we're able to look at the different layers of how this came about. So this was designed as a typical code in Vancouver. Now in Vancouver, we're kind of in that step code 2, but when we took this project on, I told the client I don't know how to do an air change at 3.5. I only know how to do passive house levels of air tightness. But if you want, I can put holes in your building to get to that score. But that's not kind of how I do. So of course the client's like, no, Shaun, work on your tightness layers to get to the passive house the levels, and we'll take that score. We know we're building for the future, and ideally you're giving a house that will be working towards the 2028, 2032 levels, and then we'll go from there. So the goal for the city was 3.5 air changes, and I'm like, no, we're going to do better. So what we've done here is created a plan. This is the back yard of the home, and we're going to go through layer by layer, so you're going to be able to see all the different components of the air barrier system. So there's the beauty. We get rid of the color, and now we just have the water shedding surface. This is the cladding. This is where water hits it, and of course it goes down and out. And you can see the windows, you can see the cladding, you can see some of the jewelry added on to make the building look good. But then once we take the cladding, we now can see the rain screen detail on the right. So you can see that ventilation cavity that we've installed to ensure that if water by chance gets past the first layer of the defense, that it can go down and out. You can see the outsulation. That's that sweater detail that we've wrapped the house. We've minimized the thermal bridges, and we've also then clamped our air barrier system to the wall. I spoke about it before about prefab. I love it. Having equipment on site is great, because when insulation arrives in your job site, it's not a few bags. It is truckloads of insulation now being brought, and having on-site equipment is very helpful to help out move, because again, labor is an issue on our job site. So it's great to be able to move insulation around and making sure that we're creating safe space for our staff and our specialists to be able to do the work that they need to do. So here is the exterior air barrier. You can see we've wrapped it. It's now nicely kind of gift wrapped. You can see the attention to detail. I will say this is I had to teach my installer to put the membrane the right way. You can see how the Mento is the wrong way. I'll show you why they did in a second. But again, is the details matter, safety, quality, production, all incorporates from a builder's perspective. And but here you can see the windows are taped, the envelope is taped. We did miss the connection there from the concrete to the membrane. That was the next step that we missed out. And you can see those boxes. Those are actually all of our airtight boxes that we put for all of our pot lights, to ensure that those airtight pot lights that you buy from the store are actually create an airtight system for our strategy. So you can see here the roof structure. You can see now the windows are removed. You can see how we've taped and made sure that the window liners, we've brought the air barrier into the inside so that we can connect it to the interior barrier that I'll speak about in a bit. So now you can see again that wrapping, the gift wrapping effort that we meticulously did on this particular house. Now, this is a roof system that is an inverted roof, meaning that we have our air barrier going above the plywood, and then we've added insulation above. So, and then we have the rain screen above our roof system. So what we had to do is make sure that our structure was properly placed. And so this is not an attic roof. This is again a beautifully handcrafted roof system. And you can see how we put in some floppy bits. Now, again, trying to teach people this is not maybe the proper vapor control material we had, but at least we had some floppy bits in there to sequencing, because sequencing is a critical term in our air barrier process to ensure that it's airtight. So sequencing, make sure you've add that to your plan about making the items through. So you can see here we've extended our air barrier strategy through the soffit to connect to that roof system, so be able to wrap around. So you can see here now we have membrane on top. We don't have membrane below, but the plywood is wet. So if you know me, I'm a wood guy, and seeing the fact that we're wetting plywood frustrates me. We should be able to deliver our membranes up faster, but we're working through codes. So what we've done is working with our structural engineer and our local inspector, that they reviewed the walls on the first floor and it was acceptable so that when our framer was building the upper walls, that they could actually lie them down and put a full sheet of membrane across it. So then when they lift up the wall with the machine, they were able to have a consistent membrane. Because again, every joint is a potential possibility of failure in our system. And so we are managing things. So you can see the floppy bit was installed between our floor system. So that would help connect our interior air barrier. You can see, again, as we're moving down through the system, how we've incorporated our prefab system throughout. I got to highlight this joint because I said earlier, one of those main joints is foundation to wall. And you can avoid this if you're taping your membranes to the concrete. But I also like this detail because it just kind of gets the framer on board of talking about our strategy where we're installing a sealant between the concrete, the sill gasket, and the subsill. Again, we're always looking at good, better, and best. And I'm always pushing our team to try to get best, just to be able to manage our risk from our air system. So there you go. The building is now back to the base. This particular one, the basement airtightness was just taped to the concrete, and then it continued upwards. But in other buildings that we're using insulated concrete foundation, so ICF, it's a sequencing issue. How do we tape that air barrier to the concrete? And so now we're sequencing our basement air barrier system to the concrete so it continues up. I'll just quickly talk about our interior air barrier because this is actually our primary air barrier, even though it looked like our exterior was the main. Exterior is just easier to do. And so when you're working on air barrier systems, it's easy to kind of see that gift wrapping with the exterior, but interior one is actually the most impressive. So you can see below that lovely flooring, below the drywall, you can see how we've connected our interior air barrier and you've connected it to the windows. And we have our interior air barrier also as the vapor control layer because we're in climate zone 4. And in this particular wall strategy that we had, we have to make sure that our vapor control layer is on the warm side. And so you can see it there all nicely taped. And so when you look at the air barrier strategy here, we actually did our mid-construction test and we got to 0.64. At the final though, we actually got to 1. So we've met our 2032 codes. 1 second, I've got a friend that decided to hop into today's presentation. Yeah, you come get my old friend. A furry friend wanted to say hi. So you can see here at mid-construction, we are really close to our goal. And as a collective, I mean, this is a team that had never thought about an air barrier strategy, didn't think about Passive House, didn't have that integrated design planning session at the very beginning where they looked at the goals. I introduced this right when the builder got involved and was like, okay, well, if you want us, this is our goal, our plan that we will deliver high levels of airtightness. And the reason we ended up getting just below 1 was some of our mechanical penetrations that were installed affected our score. But now we know, we've now been able to test the system, we have a plan, and now we've got a repeatable system. So again, the red door truth, again, I love the 475 line. The blower door doesn't lie because again, you're testing it, you're making sure it's worthwhile. So let's just kind of just quickly debrief the plan that you're going to create. 1, you're going to have a goal. You're going to set the score of what you need to get to. If you're in BC, some people might be okay with 1. However, at Passive House levels, we know the energy improvements when we get to that level of 0.6. We have people that have created repeatable systems that every time they do a blower and do a building, they're at 0.4. So whatever your score is, work towards it, achieve it. Make sure you've clearly determined what materials you're going to use in your assembly. And again, there's those critical points. Make sure you've done your red line test to ensure you got continuity. And of course, test and verify often with your blower door. And make sure you've clarified on your team of who is responsible for carrying out the plan. Builders sometimes have some kind of misclarification of who's going to do what. If you're a builder that is doing every single task, yeah, that builder is probably going to take on the responsibility. If you're a construction management company and you're hiring out specialists, who is taking on the air boss or those details? Is it the framer that's working on one phase of the airtightness? Is it the insulator? All those specialists need to be figured out Even now, you can incorporate the painter to do a liquid applied membrane. You need to figure out who is going to take on the air barrier strategies and ensure that's in their scope of work. It's been defined and that they know what needs to happen. I came across this checklist, and then I also saw our good friend Prudence create a checklist. So creating the scope of work for tightness is key. We'll put the this book in the this link in the chat so you can refer to it. But again, when you're looking at your process, document it, make sure that that plan is written and that everyone knows what they're doing. And of course, embrace the plan, communicate the plan, showcase it, make sure your neighbors know what you're up to, what every part of your crew is working. And again, here's some great signs that I've seen out in the industry. Copy and paste. Copying is a form of flattery. So embrace these signs and make sure that everyone gets it. And so, yeah, enjoy the process. Air barrier strategy needs to occur in your system. You've probably been incorporating some of those materials, but as a collective, they probably weren't, maybe classed as the air barrier system. You threw on drywall and that worked for the majority. Yeah, that could be a good air barrier strategy. But if you're putting a whole bunch of penetrations like plugs and switches, and if you're not air sealing them properly, then it might not be benefit. So develop the plan, develop your material list, and enjoy the process. And I appreciate you joining me this morning for the 101. I hope you got a bit of a taste of what it takes to put an air barrier strategy together. And if you have any questions, I believe we've got lots of time. So I thank you guys very much for having me this morning. And again, look forward to seeing your air barrier strategies and your plans. Thank you very much.
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewiso, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And thank you to our patron sponsors, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
Thank you for sure. All right, so I guess we're ready for the Q&A. Are you ready, Shaun?
I'm ready. I just started to look at them, so I think I'm ready. Go ahead, hit me.
All right, so first one from Paul Hatfield. Shaun, this is, I guess, a conversational question. You suggested we should have buildings designed to last 200 years. My understanding is that in the UK, at least, structural engineers insurance only covers them for 60 years, 60-year building design life. So that is what they designed for.
Yeah.
Is it different in the US?
No, I mean, it's same throughout. I mean, even materials, typically are going to have warranties of 25 to 50 years. But the idea is it's a phrase. I mean, in Portland, there's a building that they plan to last 500 plus years. And it's really that goal because, I mean, even in Vancouver that has a young building stock, we have homes that are structurally still there for 100 plus years, but they've been retrofitted or renovated to bring up some of the aesthetics. And so when I say 200 plus years is the mindset that when we're putting a building together, the intention is to ensure that if we're working towards a zero carbon building, that we made all the right intentions. Ideally, seismic things might change, but here in Vancouver, we have a good understanding of some of the seismic constraints. And so structurally, we know how to build it. And if we had to fix it for further things, we definitely can. But the idea is that the building should last because of all the efforts to put into it as long as we possibly can. So Paul, just to clarify that is we just want to build long-standing buildings with the right materials so that we're not having to spend time fixing them. In Vancouver, we had a leaky condo crisis. And so we've had buildings that barely lasted 8 to 12 years that had to get all their claddings replaced because we didn't do that one thing I spoke about, was keeping water out of our buildings. So for keeping water out of our buildings, that means water won't get to the structure and that structure will last a long time. And again, I've recently been in Europe, and there's those buildings that have lasted many years, including in a few that have lasted thousands of years. So again, it's a mindset, that 200 plus years.
Yeah, and Paul, if you're online and you want to add some more comments, feel free to do that. I don't know if Paul is still here. Maybe not. All right, so I guess I'll move to Karen Chu. Are you on the call to ask your question? All right, just unmute yourself if you can.
Hi, yeah, this is Karen. So I was just curious. I've been trying to do the red line test for my air barriers in general. Sometimes they run interior of the building, sometimes, but I was wondering, looking at the idea of this building you were showing, it's almost like there were two layers of red lines. Do you really do essentially an exterior red line and an interior red line when you build to this level?
Yeah, so on that particular home that isn't a passive house, and we're trying to incorporate passive house principles throughout, our wall assembly dictates that we end up having two materials. And I look at that good, better, and best. So if I'm able to reduce my risk of potential failures, I want to have more. And because of the wall assembly that we created, where you had the interior vapor control layer, could also be the air barrier. I wanted to make sure that that was airtight as possible, because in our climate, where we potentially could get moisture driving to the outside through vapor, I want to make sure that that vapor is closed off, because if there's vapor getting into the walls, this is like the building science conversations. I want to minimize the chance of condensation. And so if I make that primary air barrier on the interior side, that is a really effective way of getting it airtight. However, I'm finding that with our trades, that doing an exterior air barrier is easier at getting to the levels that we need to for air tightness. So I incorporate two because I want to make sure that I'm reducing the risk of not achieving those lower blow door scores. So you're right. I am actually, on that particular house you saw, we would have done two red line tests. And the materials that we've chosen were in place so that the vapor control was defined, and the outer material was a vapor permeable and was more vapor open, to make sure that we're getting continuous drying to the outside, but that monolithic membrane was also an airtight system as well.
You answered my follow-up question already. I was wondering about the vapor.
Yeah.
And so you make the exterior one the more vapor open so that you don't get wet trapped in there.
Yeah, I don't like making sandwich bags. Again, I learned my lesson in elementary school, where I left a sandwich in my bag, and we all know how that turned out. So I don't want our buildings to be that way. So I'm very open and conscious to make sure that we've got building envelopes that dry in both direction but are airtight. And as we move to passive house level wall assemblies, you can end up reducing your airtight layer and have one layer be your airtight membrane. And that's potential where you have lots of outsulation. And so your potential plywood or your sheathing could be your vapor control and air barrier all in one. But currently, where we're managing our step code wall assemblies, it can be a bit tricky. And so this is where it's really important that you do your red line test and make sure that it's continuous, and how they can all work together. Because on other homes where you have just a simple attic truss, like a truss system, your only air barrier is going to be that vapor control layer below your truss level. So you really need to make sure that you've developed your plan and make sure how your components connect to each other, so that you might have on your walls an interior and an exterior, but then your ceiling and roof is only one. Karen, I hope that took
All
care of
right.
your questions. Thanks, Jose.
Yeah, no problem. Up next is Ben Station. Ben, if you're on, you can unmute yourself.
Yeah. Hi. Hey, Shaun. Long
Hey,
time
how
no
are you?
talk. I'm good. How are you?
I'm great.
Great.
And you know what? Thank you for providing the our community with some plasma. You're a trooper, man.
Yeah. Gotta get. This is everybody's reminder to go get hooked up and do a donation, right?
Yeah.
My question actually is about your. I didn't really understand how the floor air barrier was accomplished. Was this? I was originally assuming that this was a crawl space, but it looked like the drainage was being put in prepping for a concrete slab. Is that correct?
Yeah. So all the homes we typically do here in Vancouver have a basement. And so the basement air barrier, or like again the six-sided part of the air barrier at the bottom of our box, is using again a more resistant vapor barrier, so a thicker vapor barrier. So that green product is a 15 mil product that again goes across the insulation. So it'll go crushed gravel, insulation, and then our air barrier, which is also the vapor control layer, that then gets taped to the concrete. And then the concrete basement is the air barrier that comes up to the wood, and then we do our details and continue up.
Oh, okay. On one of your slides, it looked like it was a concrete stem wall and then filled up with drainage rock. Was that the same project in Vancouver there, or was that just a different example?
Yeah, so the one that I kept kind of unfolding there with that example, it was just a concrete basement that we insulated on the inside. And so we added the insulation afterwards instead of doing an ICF. So that actually was a full basement. You just saw, the extra 2 feet coming up, but that was a full 8-foot foundation wall that went into the ground. And then, so in that case, we had connected the air barrier at the footing.
So you were just a transfer strip along the top of the concrete to connect your two membrane assemblies in there? Okay.
Yeah.
Okay. I was misunderstanding the project then.
No, all good. Again, I maybe I try to bounce around the examples, but like that critical point though, a foundation to wall is really critical. And that's kind of where I do 3 different connections. I do the one where you tape the exterior membrane to the concrete, the interior membrane to the concrete, if you can, or sometimes you have to manage the wood. But then I also do that sealant sill gasket sealant, and then the sill, to make sure that the air barrier continuity goes right through the concrete into the wall system.
Yeah, because that seems like a really, really tricky place to manage all those connections, and seems like a place where workmanship is absolutely critical. So yeah, I just wanted to understand that more. I'll get some pictures from you later.
Yeah, I know. It's interesting because again, a lot of buildings we work with, as a builder, you don't get to be there at the front page, or sorry, right at the first day. And nowadays we are being involved in the integrated planning process. We're there at day one. So we're able to strategize our assemblies better, our air barrier systems better. But when we are brought in after it's been designed and it's been permitted, it's okay. How do we attack our air barrier strategy that is looking at better tightness than what's kind of determined from the original design team, and knowing that, okay, they're just there to meet code. But our team knows that if we're able to reduce our air barrier system, then we're able to reduce the heating demand, and then we're able to change out our mechanical equipment, which then is saving clients money, and then we're able to move around some budget line items to make sure that they can get a more healthier, comfortable, energy efficient building.
Right on. Thank you.
Okay, we can move to David Mickey.
Yes, hello. Thank you, Shaun. Appreciate the presentation. Great information.
Thanks.
I can totally understand connecting that vapor barrier up the 8-foot foundation wall, let's say, by taping it to concrete. When we have an ICF, what does that connection look like? And how do
Yeah.
we-
So, um, maybe I can just pull this up real quick, just because it is tricky. And this is where we've been looking at it more in depth. So what we're typically doing here is, we've now started using the fast foot bags, but you either are taping to the bag or taping to your footing. And so now we have this sequencing stage where we put in a strip of our air barrier, which is also the vapor control layer, and we tape it to the footing. So now when we do the rest of it, that continues along. And so you have now a connection from footing to footing in all dimensions. So now your basement is fully airtight. And then now the concrete is the air barrier running all the way up to your walls. And that's how we we manage that detail. Does that help explain it?
Yeah, and so you're taping to the insulation, which is in turn connected on the backside to the concrete airtight, or
Yeah, so as we learned in the one picture is when we wrapped it over, we taped it to the ICF. But technically the ICF is the foam, and there's leaks in it. So
Yeah.
it's really, you want to tape it to the footing and then wrap it up and then fold it over, so that your concrete topping of your basement slab is then above your air barrier and your vapor control layer, which is then above your insulation, then which is above your crushed gravel. That's how your that basement assembly would work out well.
Yeah, I follow that. Thanks.
Yeah, and I can't wait until we have we can get rid of the gravel and the foam and put in again gravel, and so that we have an all-one product that is doing all that stuff versus multiple layers. So looking forward to new technology getting into our West Coast market.
Yeah, very nice. Kind of like a Lego system. You can buy the blocks and everything. It's tied together once you put them on.
And I tell my kids all the time, I get to go play Lego every day. Just in Vancouver, it's expensive Lego.
Yeah. All right, so we can move to John Lamb.
No, I mean, I was just watching a Passive House thing, but I'm not really
Thanks,
watching
Lindsay.
it.
Oh, Lindsay.
All good.
John Lamb is still on.
Yeah, I'm
You
still here.
can send the message. Okay, great.
Thanks, John. And this is I'm surprised Harvey didn't get in here fast. This is the Harvey question. What does things cost? So again, in Vancouver, it's a crazy market. So we're typically building for our clients in between $450 and $600 a square foot. But I have people building, and friends of mine that are building $1,000 a square foot. So the question is just, how do we make this all affordable? And this is more of a budget question of things. And so when people say, hey, Shaun, it costs more for a passive house. Well, one thing too is, there's a quality aspect. But when we, because we're trained in air barrier strategies, we're not having what my good friend Gord Cook talks about, which is the dumb tax, which is the training required for the industry to get to this knowledge. So once our industry is trained up, then we'll be able to put these systems in place and not have to incur these costs of learning how to do it. We typically say that our builds are 2% more to cost to get to high performance. But when I give the clients the key, so not only do they get the bow on the front door that says it's airtight, when I give them the key, they are making money because we've changed around the mechanical systems. So we've moved around line items in the budget to ensure that when I give them the key, that they're getting a high performance building that is comfortable, healthy, and energy efficient at no more, so that the construction costs, so their loan will be higher, but their energy bill is less. And so at the end of the month, they'll have an affordable home.
I understand. That was actually a reality check, because I keep seeing the articles that I'm reading, and they're a couple of years old before COVID, that says that, the cost of, they can get housing costs of square footage and typically across the US for about 150 to 200 square foot, and I was coming in with contractors at what your range is. And I was wondering why that was. So now I get a better feel that if it's like that in Vancouver, and that would be the same pretty much in New York and other metropolitan areas. Thank you, Shaun.
Yeah, again, ours is a Canadian. So of course, the Canadian and American currency is very different right now. So you got to add, 1.4 to do the dollars. But yeah, labor rates across North America are different. Material prices are different. Some of our material choices of why we use the products we do is because they're local and we can get them faster than some of the other ones. So, a good friend Mark says about the grocery bag is, what's the price of groceries? Price of building a house. It's all about local markets.
Thank you.
Yeah, no, that's all correct. And I would like to add one thing that also helps to drive the price down is the more you do it, the more people know about it. So, the learning curve it's just flatter. So that allows you to have more competitiveness. And like you mentioned, Shaun, the materials used also, the more they use them, the more competitivity is in the market, the more they are easily accessible for everyone. So that volume helps to drive the per square foot price down, which is what we've been observing in New York, at least, or well, when I was in New York, I observed in New York. So it definitely helps to build more and to have more people learning about it. So it's really great that you're teaching them too how to build properly. I would like to move on then to David Ayer.
Yeah.
Ayer.
Correct.
Yep. Go ahead.
Hi, Shaun. I just want to thank you for that great summary of this airtightness topic. I'm an owner builder, and I'm about to embark on building what I hope to be a fairly airtight home. And things just got a lot more complicated once you start investigating the step codes and the compliance levels and the wealth of information out there on different wall assemblies, and there's all these trade-offs that you need to consider between cost and efficiency and ease of implementation. And I'm just wondering your experience. One thing I was looking at was the BCIT site had a great series on different wall assemblies, and there's different trade-offs there for cost and ease of implementation. I'm just wondering, in your personal experience, what's the most common kind of wall assembly that you guys use? Is it just a kind of traditional 2x6 with exterior insulation on the outside? And do you find that is the systems that you use are easy for the trades to kind of pick up and run with, like they're familiar with it?
Yeah, great question, David. So I mean, ever since the step code was introduced, I've always been this person being like, we should only learn one step code, which is step code 5. They don't have to worry about learning 5 steps. You just learn one. And I, mainly focused on, the higher levels of airtightness, because that's the Passive House level. And I just knew that when you work on your airtightness goals of getting it below 1 or Passive House levels of 0.6, the clients are going to benefit from it. So we're evolving our assemblies. I'm really looking forward to probably within a year where we're only going to be using a prefabricated wall assembly. But when we have to build on site, with our structural engineers and our current, it's a 2x6 wall and then as much outsulation as we can do. The problem with that again is where you put your vapor control layer. And so now I'm still having to put in 2 membranes. I'm putting a membrane in for my vapor control layer on the inside, and then you're putting a WRB, which is your water resistant barrier, on the outside, which is then your exterior barrier. So that's one earlier kind of question was like, why do we have 2 continuous air barriers? It's to make sure that we've got the right membranes and the right building science in place. Ideally is I'm trying to convert our structural engineers to go back to a 2x4 wall with 3/4 inch plywood, and then whatever outsulation you want to put on. To me, that is a better wall system, because your outsulation could be cellulose incorporated into like an I-joist or an outsulation type thing, or lots of rock wool. To me, that's an easier system. But again, sorry, David, I mean, I know you're in Vancouver and there's other people here that are from around the world. It is all about climate zones. In BC, you just have to be be aware of your climate zones. And you did hit the mark on BCIT has an amazing array of wall systems. And they've got 4 or 5 ones that are typical part of the step code learning phase, where different materials and different choices. But I kind of gave you a hint on my preferred wall, and we could definitely talk offline about some other details. But again, continue checking out BCIT's resources and their courses, because that high performance lab is pretty amazing for all the mock-ups they have. I think it must be like the leader of all mock-ups in probably the world for how many mock-ups they have for high performance stuff.
Yeah, it's been really helpful. So thank you.
Yep.
All right, thanks, Shaun. We have a couple more questions, but we would like to give a little space to the sponsors before the top of the hour. So Kim, go ahead.
Thank you so much, Jose, and thank you, Shaun. Let me just share my screen here. I'm just going to go through a couple upcoming events and happenings to let you all know about. First off, our podcast episode this week on the Passive House podcast is with Heather Mott. She is a in-house designer of Passive House model homes at Collective Carpentry. Next up, we have, for those of you, I guess, new to the accelerator, welcome. We have a free event every Wednesday at 12 p.m. Eastern, 9 a.m. Pacific time. And next week, we will have our Next Gen series. We will be joined by Linnea Kreuzer. She's a student in Sweden and recently took this really incredible trip across 20 countries in Europe, visiting 150 different manufacturers and passive house projects. So she will join us to speak about that. And the following week, we will be joined by the team that designed a passive house portion of the Bush School in Seattle. We will be joined by Dan Swab and Brendan Connolly of Methuen and David Mead from PAE, and they will be talking about a healthy haven for learning. Next Thursday, we have our first component spotlight event of the fall. We will be joined by Brad Moore of 475 Supply and Muscle Ridge Builders, and they'll be talking about mass timber weather protection. This is next Thursday at 12 p.m. Eastern, and there is a link in the chat to register for this. A couple more things to share. We have the Passive House Network event coming up, conference coming up in just about a month, October 4th and 5th. So be sure to check that out. And there is also a design award submission deadline that has been extended until September 7th. And finally, a reminder for those of you based in and around New York that the NYSERDA Buildings of Excellence Competition Round 4 is open. The deadline is, I believe, September 21st. And they'll be awarding up to $1 million for projects. So be sure to check that out. I know we have lots more questions to go through, so I will hand it back over to you, Jose.
Yeah, thanks, Kim. I, for one, am really excited to see everything that's coming up the second half of the year. So if everyone has some more time, we have around 4 more questions. So this should be pretty nice. The first one would be from Harvey Minnock. Harvey, go ahead.
You're muted,
I can
Harvey.
hear you. You're unmuted, but somehow your sound's not working. Now pull that plug.
Oh, bummer.
Oh, Harvey. Our wiring
It could be the headphones.
which is cost.
No?
Yeah. There we
there
go.
you go.
Here you go. Yep. It's good.
Now it's working? Okay, so it may be my headphones. Great presentation. Zach, nice to see you. Mark, nice to see you. All the other people I've seen throughout the years, nice to see everybody.
All the new people.
I just want to add one question first, but I'll go to the question I had in the chat box. What's the lessons learned that you've taken from this build or another build that's high performance that you have pushed forward with onto the next job? And that would be the question number 1 to answer, and then I'll get on to question number 2 in a second.
Sure. You know what? It's about the repeatable system. I was lucky again before. I was working with 475, and so I had worked with the installation and crew, and so I knew that they knew the materials that I wanted to use. They knew the details. And so being able to work with the team so that now we're incorporating the same process and procedures into the next, because again, the building industry changes, people come and go, but trying to create a repeatable system so that everyone understands, hey, every building's like, oh, there's Shaun putting on floppy bits again. Everyone understands what those floppy bits are about, how they work together. And seeing also, so the first one is the repeatable system, but kind of the what I've passionate or I'm really happy to see is the specialists starting to take it upon themselves, where they're like, hey Shaun, where's those gaskets? The plumber now, he puts the gaskets on himself instead of me, having to cut them and prep them and get them. They're already asking for them. So having a repeatable system and having people buy into to understanding why airtightness is important and adding into the scope work and then delivering it was really great. And we're now, we've got 5 projects since then that we've been able to use since then, and be able to hands off and having my site supers do the air barrier details is great. So repeatable system, make it happen, create that plan, develop it, repeat it, and grow.
Okay, so here's the second part of the same question, I guess.
Okay.
One would be mock-ups. How often are you doing them on site? And then the second
Every
thing
time.
is, I'm just wondering, you were talking about repeatable. How far down the road are you at Clay Construction to have almost like a YouTube style of okay, you're the plumber, here's what you have to be concerned about. You're the electrician, here's what you have to be concerned about, air barrier, etc. That you send that out when you have a kickoff meeting. That I've seen people are using QR codes. Why would we not have a QR code or something to that effect that was used by everybody here that's sitting in Passive House Accelerator, that each person can use towards, like, we've had a lot of questions, and it's always the same detailed questions, always about air barrier, from foundation or from footings to foundation to wall to roof, etc. All those pieces should be something that on a kickoff meeting that we all have access to, and they're 30 seconds, a minute, or whatever, that have all the details. And if anyone else needs it, you can always refer to it. Did you on site? Did you do it? I'm just wondering if that's come through, if that's a thought process that it's similar to a mock-up, but I think it would be really beneficial to even people who are on the show today, that they could just quickly go and take a look at what we're talking about.
All right, so you gave me 5 points, so we'll go through the 5 points. First one is I've been using the same mock-up since day one. I built it at BCIT, and now it just carries from job to job so that everyone understands those major connection points. And it's really nice for the clients to kind of get an idea of like what that looks like, because a lot of times they drive by and they see white membrane everywhere, and the white membrane is not really on proper. And so when they see a black membrane, and I tell the clients, just kind of like what Henry Ford said when everyone wanted a Model T, you're gonna have it in black. Well, guess what? You're getting a high performance house from Clay in black. It's what we do. This is how we do it. We tape it in blue tape, but that's how we deliver it. On the portion, I mean, you think of how things have evolved in the last 3 years during COVID with how many accelerator presentations we've done. There is stuff in the works to make sure that we do it. We actually do use the QR codes on our job sites now. I can't remember where we saw it on Instagram, and that's where we have all of our drawings, our safety info. We have I think about 12 different QR codes for our specialists to view when they're on our job sites, so they can access the right information, the most current information. And we actually now do an integrated planning session with all of our specialists before. So, as a company, we're incorporating continuous improvement initiatives throughout the process so that we're having a safe job sites, quality job sites, and then with good production in that order. And then it comes back to, it's like, how do we make the continuous improvement process faster and better with training, all the specialists. And so, yeah, training is a big thing. I say that I educate every day. I hate to say that I manage, because really we're just trying to teach people and make sure that they're on board with the process. And so yeah, you're going to see more of those videos. And I'm sure if those are not familiar with Instagram and me and Larry, we document a lot of stuff we do, and we'll continue to do that. And I know we have other amazing individuals in our industry that are showcasing their work in all the different social media streams. And so it would be nice, you're right, to have, a central source. But the fact that you can at least Google on YouTube certain details and they pop up pretty quick. And again, all the sponsors that we have on the accelerator have amazing resources. And so, you got to do the legwork to find out your system and your strategies, but those answers are there, and we'll keep refining it, not only here at the accelerator, but in our industry. And I know that you'll keep checking on me to make sure that I'm providing you with free, accessible resources so that we keep our costs down, right?
Well, you know what? A free time's a good time is a theory that I've always had.
Hey,
But great presentation today. Thank you for that. And thanks, everybody.
And if it's spelled with PH, I'm happy to give it out for free.
Hey, thank you, guys. Thank you, Harvey. Thank you, Shaun. Up next is Bill Schaefer.
Yeah, hi, can you hear me?
Yep.
Yeah, hey, Shaun, thank you for the presentation. It was great. So I work on the commercial side primarily. So I use the term as built here, but part of my question really comes down to, you mentioned this idea of like the 200-year building, like building something that's going to last 200 years. And my thought process there is, okay, we're going to have a building that lasts 200 years. Are you going to have an air barrier that lasts 200 years? And I'm thinking of the cable company coming in and drilling a hole through the exterior of the building, or an electrician coming in 20 years and putting in new lights. My question to you is, as a builder, how are you communicating, whether that's through as-builts or photos or whatever, the work that you've done, so that somebody later on down the line can come along and maintain that air barrier? Because I feel like that's not something we talk about a ton in this community. But I'm super interested on, how do you, and your pictures are great, and I feel like as a builder, I would be able to pick up and understand a lot of what you're doing. How do you communicate that to a potential future builder?
Yeah, so we used to use a system called Multivista, which we would video every single wall and roof before we put the drywall on, or before we put on the insulation. Now we do that in-house. So our clients literally get a chip, but soon we'll have a bit of an online resource so that they will be able to go and look at every aspect of their house behind the drywall, so they can see things. And so that's kind of how we document the process. We do that. The middle of construction, we again look at what's behind the drywall, and then of course we do it once the drywall's on for kind of marketing and advertising. But that we use a lot of photos. Our software that we use with our daily process. So when we finish a project, the client's going to get access to thousands of photos during the construction process, and then also another package of just right before we added the insulation and drywall of what's in behind the wall. We also do another thing too, is to help out the drywall. We actually mark our floors with all the items that we have in our walls, so then our drywallers don't forget things. So those kind of two tools of documenting visually and marking help out our process. And again, this is stuff that I've learned from other people, and copying is a form of flattery. And so being able to adapt and learn from other people is how we're going to grow fast and furious. And then when it comes to the walls, this is why I like that 2x4 wall with insulation, because it's great that we have a rain screen to create ventilation and drainage cavity on the outside of our wall. The service cavity is also a great protection of the air barrier, because we're running all of our electrical and plumbing in that service cavity, and we're protecting that air barrier. So, that wall assembly choice can really affect that kind of like 200-year strategy by making sure people can't get to the air barrier. It's just encased in that wall assembly or roof assembly for life. We're using products that have been tested for 100+ years. So I know that adhesion and that connection is going to last a long time. And if we clamp it in place with the different materials, again, it'll last even longer.
Great, thanks. And just a quick follow-up question. How are you educating the client, in this case, a homeowner, presumably, about about how to maintain that air barrier. So again, let's say, in 5 years, maybe probably less, they're going to decide they want a light, outside their door. And how are you educating them so that they can communicate to an electrician that they hire, hey, here's what you need to do to maintain this very important part of my home?
Yeah, well, hopefully they'll call us back and we'll be involved in that process, which most of our clients do. Again, a good client and a good process means they're a client for life, and they'll call our trades that are educated with it. But again, giving them the tools and the knowledge, we can lead them to water. After that, it's up to them, and hopefully though we've encouraged them and we've got them to believe why the air barrier is so beneficial and why we worked hard to get them to those lower levels of air tightness, that they don't all of a sudden just take over the house and forget about what I said and just start poking holes everywhere. So again, we can do our best, and this is where I want to be able to work with the clients and go back in 4 or 5 years and test it and say, hey, can we just test our strategy and see how it is? And I think good clients would want to know that research. And I mean, I know there's a lot of risk and warranty things with that potential thing, but if we're able to do what Wolfgang did it every 5 years, test it and get the same air, air tightness levels. And of course too, is we can always do a smoke machine and say, hey, you did screw this up and we could fix it, but at least we could be able to document, do the research. So it's all education, it's all learning process. And if you get clients, and most of the ones we're getting, got into learning about healthy homes, and then we have discussions of what a healthy and comfortable home is, and then we talk about how we get there with Passive House principles.
All right, thanks, guys. So we are down to the last question from Peter Molinar.
Hello, good afternoon. Good to see you all back. You enjoyed your holiday?
We did, absolutely.
The question is, would you work with a contractor again now that they're familiar with high performance building techniques and technologies?
Yeah, so for us, I mean, we strive on creating like an A team where, and I mean, we're a builder, but we're really more of a construction management company where we hire out our specialists. So keeping our core specialists, is really important, and managing that team. And so when I say the team, I'd say the big ones are the mechanical, electrical, plumbing, because they're the ones typically poking a lot of holes through our air barriers. So making sure that we have a trustworthy team that we can go back and use. And as a contractor, you do need to go and get 3 quotes from everybody, but we're pretty tight with our, I'd say, A team, ensuring that we have that repeatable system, not just on our air barrier system, but also through the entire process, because air tightness is a part of the scope of work in building, but there's a lot of other tasks that have to get done. And a friend of mine says there's 1.4 million decisions to make in building a house, and we have to get to about 80 as fast as we can. And so when you have that repeatable system where you can minimize those choices and just repeat, helps out that process so that it can be cost effective and still beautiful at the same time.
How many signs of "don't drill the wall" did you put up in this case?
As many as 475 can get me, because again, why recreate something that looks so good? So every time I'm at a trade booth, I definitely pick up a few and put them around. And the first conversation I have is when someone brings a tool that I know is going to hurt things, be like, you better know how to use that tool, because if you use it wrong, you're going to be fixing things. So yeah.
A lot of tape. And your suggestion of doing 2x4 structure and outsolation, plenty of that. Good idea.
Yeah.
With Larson Truss.
Yeah, so I mean, typically it's upgrading from 1/2-inch ply to 3/4-inch ply, so that your shear wall and process is a bit more rigid with it. And also too, is RDH did a really good study about only having to hit about 15-20% of your studs when you go from 1/2-inch to 3/4-inch. So there's a lot of benefits by communicating with the industry to see some better methods of doing things. But then it comes back to the affordability. How do we build shelter for the masses and have a repeatable system and be able to use products that are readily available and can be replaced. It's a challenge because there's a lot of different options. I mean, we're lucky in construction to have so many different options out there. It's just a question of how do we use materials to create a repeatable system so we can keep our costs down and ensure that we're creating again, a healthy, comfortable, energy efficient home for our clients.
Thank you, Shaun. Great explanation of good projects, and thank you very much.
Very welcome. Good to see you.
Hey, thank you all. Well, if we have time, I think we could go with M. Reynolds. I think we skip his question if he's still on, because we have a couple more minutes if everyone's okay with it.
Yeah.
Hello.
Hello.
It's Margaret Reynolds.
Hey, Margaret.
Oh, hi, Margaret.
Looking, working on a project in New England, so it's going to be different materials from the Pacific Northwest. I'm trying to get my mind around how you make a basement airtight and then carry it up into the timber frame. So what you were talking about was really useful. And it sounds like you suggest, you were saying the airtightness goes underneath the slab and then comes up the sides.
Yeah, so your air barrier, which would be your vapor control air, so either poly or a thick poly, I recommend thicker the better. Is taped then to your footing, and then the concrete becomes the air barrier.
Yeah,
and then that continues up. Yeah, I mean we like on that what I described in our presentation today. We actually did use Intello on the interior side, because we didn't have outsulation, and I was just worried about the foam and the concrete and some vapor issues. So we did use we went vapor control air at the basement to then vapor control in the wall, and then continue that up to the floor system, and then transferred it upwards. So
well, I would love to use only a 4-inch stud wall on the footing wall, with plenty on the outside to sort of line with the insulated concrete formwork. But how are you going to fix that without making cold bridges in through it?
Yeah, so when we do our basement 2x4 wall, we pin it to our sill, or depends on where the floor system sitting on top of the foundation wall, or if it's connected, can determine how we do it. But we will either put in a bunch of blocks at the top of the wall and separate it so that you have that 1/2 inch, so you have a 1/2 inch gap between your, in a sense, basement surface cavity wall and then your insulation.
Yeah.
Definitely a couple different strategies, but like overall, in a sense, the air barrier of your basement is the concrete.
Yeah, I can see that. Not the footing concrete, just the slab concrete. And how would you fix through 4 inches of external insulation back to the stud wall?
On the interior side or on the exterior side?
External.
Yeah, so on the exterior side, if you're not using ICF, you in a sense you're just gluing it, so you can pin it with some nails, and then you glue it, and then when you backfill, the backfill puts against it. So what we typically
I meant up higher, when you line the wall external insulation on the 4-inch stud wall, you've got to fix that back to the studs, and then you want some battens for the cladding. So it's a lot of fixing, hanging on 4 inches of fluff, as you say, without making cold bridges. So I can't see how you could glue that.
So yeah, no, I apologize. I'm just trying to visualize the detail, but also my good friend Mark put in the chat that Mr. Steve Basic has this detail on a local show, and it clearly defines it. So I'm like, I don't want to say refer to that, but that's the easy answer.
Yeah. Okay.
No. Again, the detail of, again, the continuity and of course, of the process is achievable. Again, it just needs to be thought out about it. And I think I'm kind of getting to the last of the presentation where I'm a bit burnt out and I can't visualize your point, Margaret, but maybe we could take it offline and I can dive into it.
Thank you very
Mark
much.
might have the answer.
Right. Thanks.
The fasteners on that would be a small percentage of thermal bridging, correct? And I guess the way you look at that is there's always the weakest link, right, in all components. And so there's a percentage there that can't be modeled, but you're building the rest of it for that continuity. And we need the fasteners anyway. So we accept that. That's how I look at it. We accept it as the weakest link.
Yeah. Okay, good. Thank you very much.
And what's nice too is this community has done some amazing research. Like I just kind of default to Enrico over at EMU, where he looked at, you know, the thermal bridging of all those fasteners and, you know, gave us some really good analysis of different kind of cladding systems and you know, not even looking at the cost of it, but looking at thermal imaging details that, I mean, again, I never would have thought of 3 or 4 years ago, but now having a little bit of knowledge and making better decisions and like, oh, hey, I might not know the exact, you know, detail, but I could call Enrico and say, hey, you did this amazing study about fasteners. Can you reference it so I can give it to my energy advisor or code consultant or Passive House consultant, and we can, you know, review that assembly versus another one. I mean, this is what I love about the communication, is just this all about this collaborative approach to finding these answers. And again, so I enjoy doing these presentations and trying to educate the industry, and is to also work on my craft and work on my passion, but be able to collaborate with other people and fine tune things. Like I look at indoor air quality. I never would have thought of indoor air quality until I went to a Passive House conference in Oakland and learned about air quality. And now when I see people putting gas stoves in, I'm like, why? So, you know, again,
thanks for Frank for the presentation today and for all you do for this whole enterprise, which is just brilliant and really helpful for the builder too.
Appreciate it. Thanks.
Yeah, thank you all. That was a really great way to finish it. And I think what you just said is correct, Shaun. I mean, it's a really collaborative community, and I'm really happy to be part of it as well. And yeah, I mean, if anyone has any questions, everyone around here, the Passive House community is really open to conversation and just figuring out details and, you know, setting up at some point a library we could all have on a QR code and just, you know, share it around. I mean, that would be ideal. So with that, I guess we'll see you on the next event on next Wednesday, the next generation. And yeah, I guess we can finish it. See you all, and thank you.
Bye,
Thanks,
everyone.
everybody.
Bye.
Thanks, Shaun. Thanks, Jose.
Ciao.